on the video, and I got part 1 in a hair over 2 minutes, and part 2 at a hair over 5. And so I went to look at the leaderboard. And I was like, "Oh, that's awesome! 2 minutes, 2:01. That'd be 7th." Yeah. This is for both stars. I forgot how competitive the very top of the leaderboard is early on with simple problems. Yeah. So 5 minutes, I didn't get in, and 2 minutes, I didn't get in. So yeah, I tend to do better on the mid-range problems or the really hard problems where I have an algorithm already ready to go that can solve it. Such as I have an A-star implementation ready to go, and a coworker a couple years back taught me that I can turn an awful lot of actual problems into A-star problems, especially when you're not overly concerned about the world's most efficient way to solve things. You can turn a surprising number of optimization problems into A-star. Or rather, you could hack an A-star algorithm into solving quite a bit of optimization problems. Anyway, I am just going to do a little bit better job of keeping track of my start and whatnot time so I can get an idea of where I'll fall or where I would have fallen on the leaderboard. Judging by how day 1 went, I'm pretty sure I probably wouldn't have been anywhere on it for day 2 either. But again, I haven't looked at the problem. So I will confirm. Yeah, okay, so I have day 2 wired up to go. Yeah, so I basically have these files preset to handle this. All right, so I will start at 9:30. We'll start at 9:31 on the dot. That should make it easier to handle. So as soon as the clock down here flips to 9:31, I will look into the problem, and we'll see how bad day 2 is. All right. Oh, fun. Like we're doing a little bit more. Oh, nice. We got tons of numbers. All right. Let's run. Oh, nice. You have these set up so you can double click to copy them. Kind of cool. All right. List of integers. Oh, are we doing more opcode fun things? Oh, this is fun. 99, da da da. Values is write the value at position 30. Okay. Okay. Direction pointer 0. Commas. All right, so now we've got an integer. We're going to start with 0. And okay. The next one by stepping forward 4 position. So this is our standard. We usually have several of these each year. Where we simulate something or other. Okay. This. We have 3 opcode. 1, 9. Just in case. 1 as 2 and stores back at the other. So 1. That's it's the positions. Oh, okay. No, we're going to get a halting version of this, halting problem version of this later on, where you got to detect a pattern or something. It's how we always do. Okay, so then break. Playing. Step is program. Okay. We're running the program. Value position. Program 0. Okay. 0 is implemented. Nice. Oh. Plus equals. Actually, might have to run out the whole state. I lost that. All right. So 9 2 0 off 1 12 that was at 936. Cool. So what are we going to do for part 2? By the number of opcodes. Opcode. Okay, it's a structure pointer. Say values and add more. Got it. So this 4 is going to change in the future. What pair of inputs? Oh. Noun verb. Oh, this is the Apollo guidance computer. Oh, spring was halted. Oh, interesting. Okay. So, let's see. It'll effectively let us clone it. What? Noun and verb will be two. Yeah, we could brute force this. So, well, these are noun and verb. Noun. By the way, you know in a future one, they're going to say, okay, just make noun and verb 1,000,000 and ask us to somehow solve it too. Oh, actually, this equals loop. And then what would that? Yeah, you can tell I wrote triple equal. I've been writing JavaScript recently. Might just want to write everything out. Doing. Nice. I didn't get a good answer. I didn't get a working answer. It, oh, because I'm resetting to the values. Wait a second. That number just keeps up. This, I didn't do this right. I don't think I actually cleared my array out. I did. Yeah, it's not. Address 1, noun, 2, verb, 0 and 99 inclusive, noun, verb, noun, verb. I'm not doing. By the way, digressions like this are why how a very easy way to not do all that great. Right, so see, we're resetting. Yeah, I'm resetting before we start, so that's not what I'm doing wrong. All right, let's go back and reread this. I must have missed something. Add all the instruction starts at 0. Yep. Up by 4. Yep. Three. Verb. Each of them will be that. Something. What is it? Structured verb. Verb. You know what? Let's just. This isn't the thing that's going to kill us performance-wise anyway, so let's just reparse it every time. Noun, value, verb. Wait a second. Let's look at the pattern here. I should have seen that 9, 19. Right, because we got a pattern here, so let's figure out where it should have landed in the pattern. 6, 9, 0, 17. Oh, I just didn't have it abort. I am stupid. And that's at 4331. All right. So, wow, I am not gonna. This is not gonna be a good score. 1231, and I'll go back and look at the stream. But I'm betting, had I put the turn here that I was thinking about, I would have saved a whole ton of stuff. That would have probably been at least 3 minutes off. Again, this is a perfect example of I had the basic algorithm right, but under the time pressure, I missed something really simple. Okay, so let us go back and see where the leaderboard sat. All right, so 531. Ooh, that would have put us on the global leaderboard at 57. I'll give that person the benefit of the doubt. I'd have been 58. 1231, however, puts me off the bottom of that one. And actually, I'm just going to mute the stream here for a second and go back and check. And I'm betting I'm betting I could have shaved at least a couple minutes. All right, so 7:23 on stream, or 7:29 on stream. And let's see, when did I first run? That was quite a ways past. Yep, okay, so I ran it for the first time at 10:56. Give me a few minutes to spit it over. That would have been at about 11:0. Oh, actually, I need to know what point I started. I know I was talking for a little bit before I got going. I started at 1:50. This was... Ugh, I have to do math. 5:31. Just the same number I came up with the other way. And then this would be N3. So 10:33 would have been right at the very bottom of this anyway. So I've been about 94. Oh, 94 was 34. Yeah, 10:33 would have been about 94. So I still didn't do that great anyway. So this one would have been legit. This one I would have been off. But yeah, still interesting. Like this just has the telltale thing. Like last year, there was a similar simulate the computer thing, except that one ended up turning into a guess the pattern and figure out the halting thing. So actually, it wouldn't be a horrible idea to do the work to figure out what this pattern is. Effectively, build the formula for given n and m. Work out what the formula is for the algorithm. But my guess is there's no way we'd be given this same input here. So if it's anything like last year's, what you end up having to do is translate the code, or translate this code into the instructions for it. So like translate it into a language you can understand a little better, like say JavaScript or Sharp or whatever. And then you have to basically go through and simplify it. So this things like usually what ends up happening is we get a lot of basic operators added to this, and then you get things like just enough conditions like a goto and a comparison and so on, so that you can do basic looping constructs. Like last year's I think was something like it was like prime number factorization with for loops or something, but you could massively cut down on the number of instructions if you could recognize the patterns that simplify. So you effectively would build out a simplified version of the problem you were presented with, then run your simplified version as code, and you were in business. So I wouldn't be surprised if that's where this ends up, but if it's anything like the other years, this will get built up over several nights. So we'll gradually add more operators, making the language more complicated and so on, and then culminate it with okay, now can you, given some new problem that we've, or new input string that we've not seen before, but with the same basic machine, definition. You'll have to figure out what it is that it does, simplify what it does, and produce an output in several billion fewer instructions than what would be taken to actually simulate. But actual simulation will get you quite a ways. So I'm probably actually going to build this up into a, going to refactor this a little bit to better work off of the opcode and whatnot. Actually, it probably doesn't need to be factored much from what it is, but I'll probably tweak it just a little bit because I'm betting a future night. Anyway, I guess that will call it for the moment. That was day 2. If I'd have been actually competing, 58 wouldn't have been a bad haul of points for the night. Actually, it's not. 58 place, which is like 40 something points. Yeah, 40 something points. Plus, it would have really helped my private leaderboard. But that's okay. Yeah, I don't know. Thing is I said I wasn't gonna actually leaderboard chase, but now I don't know. Who knows? Hopefully I'll be able to help myself, but who knows? Anyway, that's it for day 2. I'll probably do day 3 tomorrow evening, or maybe if I'm bored and up at 11 o'clock, I'll do it then.